All right, now that we've gone over all of our types of reactions, I thought it might be helpful to do one more together so that you have all 5 types to pick from. And this one's going to be a little bit more complicated in terms of building the products and balancing the equations. So I thought it might be a good idea to go through a little bit of a more challenging example. So we have AgNO3 and MgCl2. So the first thing we need to do is identify what type of reaction this is. So you look at what you're starting with. AgNO3 is definitely a compound. There's more than one element there. Same for MgCl2, also a compound. So we have compound plus compound. If we go to our shortcut code list, we know that compound plus compound means double replacement. And double replacement means we're switching partners. So let's build those compounds. I can look up NO3 on my polyatomic list, and I know it's a -1. That tells me, since I only have one Ag atom to balance it with, that Ag is a +1. So we have AgNO3. Then for our other reactant, we have MgCl2. And that makes sense because I know from my periodic table that Mg is a +2 and Cl is a -1. So they're my reactants. So then we have our arrow. And what are we going to make for our products? Well, we have to switch the partners. So that means the positive things are going to switch places. And it has to be just the positive and the positive switching places, because you can't put 2 positive things together on the product side and expect them to make a compound. You have to have a positive and a negative. So on the other side of my equation, that means that I want to put the Mg with the NO3, and I want to put the Ag with the Cl here. See if we can move those over just a little bit. Okay, so now I need to check my charges. So Mg is still a +2, NO3 is a -1. That means I need another NO3 to make that a valid compound. And then I check my charges here, +1, -1, those are good. So my products then are going to be MgNO3, but I need 2 of those. Uh-oh, that looks like NO332, so I need to put parentheses in here. MgNO32 and AgCl. All right, now we got to balance the equation. So we have one green one, one green one. Good so far. One blue one. Uh-oh, 2 blue ones. Okay, so that means I need to add, to scoot these down a little bit. That means I need to add another blue one to the reactant side, but this is part of a compound, so I can't just add a single ion like that. I have to add another one of that compound. So we have 2 AgNO3s there, and check the blue ones again. Okay, 2 blue ones, 2 blue ones. So then, okay, what else do I have to fix? Now I added a silver, so that means I'm going to need another silver on this side, but I can't just add a silver. It's got to be that compound that I add, so AgCl. And then let's see, 2 green ones, 2 green ones, 2 blue ones, 2 blue ones, 1 red one, 1 red one, 2 pink ones, and 2 pink ones. All right, so now I have to count the number of molecules or compounds. They're not really molecules. This is ionic stuff, so they're formula units, but it's kind of a nice way to think about it. So we have 2 AgNO3s, so we put a 2 here. Then we have 1 MgCl2. Then we have 1 MgNO32. And then we have 2 AgCls. So we have a 1:2 kind of ratio here going on. And that one is all done. So hopefully this helped clear up some of the confusion. And if it hasn't, go ahead and shoot me an email or comment in Classroom.